Good afternoon, everyone. Thank you for joining today's Technology Spotlight. We'll get started in a few moments to give everyone some time to join in. All righty, it's 2 after. Let's get started. So welcome everyone to this month's Department of the Navy Oracle Technology Spotlight. For today's topic, we will be discussing Oracle Java in 2025, tackling challenges and driving innovation. My name is J.R. Lazo, and I'm the Oracle Account Manager supporting the Department of Navy here at DLT. Before we get started, wanted to go over a few housekeeping items. For Dawn customers on NMCI, we recommend using the Zoom link to view today's presentation. If dialing in, Zoom features would not be available. All lines will be muted during the presentation, but if you have any questions, please feel free to enter them in the Zoom Q&A. We will address these questions throughout the presentation, but we'll also have some Q&A towards the end, time permitting. If you have any technical issues, please message Felicia Cortez or the panelists via Zoom chat. This tech spotlight will be recorded and a copy of the recording will be made available next week on the Dawn Marketplace. If you'd like a copy of this brief sent directly to you, please enter your name and email in the chat section and we will send you a copy once available. So quick overview of today's agenda. To lead off, I will be providing an overview of the Dawn Oracle 3 Enterprise Software Agreement. I will also be providing an overview of the Navy Java consolidated by, which you may have received a task for that is due next week on 4/4. And we'll also review how you can ensure your Java requirements are included in the consolidated order in order to achieve maximum cost savings. Then Jerry Andrews, Principal Success Consultant with Oracle, will be discussing Oracle Java in 2025, tackling challenges driving innovation. So a quick overview of the Oracle 3 Enterprise Agreement. In May 2023, NAVSUP awarded DLT an enterprise software agreement for Oracle licenses and services for a 5-year term. Authorized users of this agreement is the Department of Navy, including U.S. Marine Corps, and approved contractor support. The managing activity for this agreement is the Enterprise IT Strategic Sourcing Program. At the bottom of this slide, you will also find a link to the DLT Marketplace, which is where the recording will be made available, but will also have information and resources regarding the Oracle Enterprise Software Agreement. The Enterprise Agreement can be broken down into 2 distinct parts, the Unlimited License Agreement and the Agency Catalog. In regards to the Unlimited License Agreement, authorized users have access to unlimited use of Oracle Core Technology licenses, including maintenance and support for these licenses. Core Tech licenses include all versions of Oracle Database, WebLogic Suite, and Database Management Packs. The Unlimited License Agreement is essentially funded by the Department of Navy and Marine Corps. In other words, what would typically cost around $60,000 for a single server license of Oracle Database is now a $0 ITPR as a result of this agreement. Navy users can obtain access to these licenses by submitting a memorandum of agreement, or MOA for short, through the DLT marketplace. In regards to the agency catalog, Navy customers can procure most of Oracle remaining software licenses and cloud services, including Java, that are not part of the unlimited license agreement at a pre-negotiated discount via the agency catalog, which has static pricing through May 2028. To procure licenses and cloud services available on the agency catalog, authorized customers should reach out to the DLT Navy Oracle team for ordering procedures. As a reminder, per the DON CIO, the enterprise agreement is a mandated source of supply, where all DON organizations and programs are required to use this agreement for their Oracle needs in order to achieve maximum cost savings through May 2028. This slide highlights the key benefits of the Oracle Enterprise Software Agreement. I won't read into each one, but there are a few I want to highlight. First point is that the ESLA ESLA improves Navy's buying and negotiation power for maximum discount and cost avoidance. It also provides a centralized ordering platform via the DLT marketplace, which enables greater visibility, oversight, and control over software procurements. It also eliminates the requirement for a justification and approval, or JNAs for short, for catalog purchases at the ordering level. Last point pertains to licensing virtual environments or virtualized environments. This agreement allows DON customers to reduce costs by using virtual processors as a license boundary for Oracle software calculations. This slide summarizes what Oracle software is available via the unlimited license agreement and the agency catalog. To reiterate, in order to gain access to licenses available on the unlimited license agreement, i.e. the licenses on the left-hand side of the slide, you would need to submit a MOA via the DLT marketplace. To procure licenses on the agency catalog, licenses on the right-hand side, you would need to reach out to the Navy Oracle team at DLT for ordering procedures. This slide details who are authorized users of this enterprise agreement, but to summarize, it's all Department of Navy organizations or principal elements of the Navy can leverage this contract, except for when the Navy is serving as a Department of Defense executive agent, an entity which Department of Navy is serving as a DoD combatant command support agent, and Navy special access programs. This slide has a link to the marketplace and a screenshot of the homepage, but if you need assistance with accessing the portal, please reach out to the Navy Oracle team at DLT. This concludes the DON Oracle 3 Enterprise Agreement overview. Next item on the agenda is an overview of the Navy Java Consolidated Buy. Some key points or takeaways we'll be covering in the next few slides is an overview of the Consolidated Buy, the benefits and advantages of the Consolidated Buy, frequently asked questions, and call to action. Specifically, the deadline to participate in the Consolidated Buy is due next week on the 4th. So what is the Consolidated Buy, and how does it benefit my organization? In summary, NASA FLC contracting will be placing a consolidated order for Java subscriptions via the DON Oracle 3 Enterprise Agreement for all authorized users of the DON of this agreement. If you have a need for Java software or currently have it deployed, it is highly encouraged you participate in the Consolidated Buy. The objective of the Consolidated Buy is to ultimately achieve maximum cost avoidance for the DON for all net new and renewal Java requirements. The period of performance of this Consolidated Buy is May 31st through May 30th of next year. But bottom line up front, if you're looking to procure Java, this Consolidated Buy is the most cost-effective option to do so. Next few slides, we'll be reviewing the ordering process for the Consolidated Buy. Step 1 is to reach out to the Navy Oracle team at Navy Oracle team for all Java requisitions. If the reference Java requirement is for renewal, please provide the associated CSI number or previous DLT quote number. Step 2 is to validate the Java requirements using the Oracle hardware capture sheet as a guide. And there's a screenshot of the capture sheet included in the slide as well. A hardware count sheet is used as a guide to help determine the appropriate number of Java subscriptions required for a given system or server. Once a Java requirement is validated by the Navy Oracle team at DLT, DLT will issue a quote to renew or procure Java for your requirement. Step 3 is for ITPRs for Java must be submitted to NAVSUB via ProTrack no later than close of business on April 4th. If you cannot provide your funding by April 4th, you are still required to submit your funding and purchase request to NAVSUB as soon as possible to avoid a lapse in your Java subscriptions. NAVSUB will still process your Java purchase requirements received after the 4th. However, standard catalog prices will apply and will not be included in the consolidated order. Step 4 is for any discounts gained by NAVSUB, NAVSUB consolidated order will be applied and excess funds can be rolled back or will be rolled back after the order is issued. Below step 4, I included unit pricing information to convey the cost savings of a standalone purchase of Java subscriptions versus a discounted cost via the consolidated buy. In summary, customer in this example saved around 40% in software costs by participating in the consolidated buy compared to a standalone purchase. But quick disclaimer, the unit cost reference in the discounted cost section is based on the quantities acquired for the current consolidated buy term. So some frequently asked question is that is this consolidated buy only for new Java requirements? No, it's highly recommended for all Java requirements, either net new or renewal, to participate. What is the period of performance? As previously mentioned, it's May 31st through May 30th of next year. The period of performance, and another common question is the period of performance for previously acquired Java subscriptions do not align with the consolidated buy term of May 31st to May 30th. Can these subscriptions be renewed via the consolidated buy? In summary, yes, and please contact the Navy Oracle team at DLT to discuss. We would ultimately need to co-term your Java subscriptions to align with the period of performance of the consolidated buy. Last frequently asked question is, will the CSI for previously acquired Java subscriptions remain active? Answer that would be no. A new CSI was issued as a result of this consolidated order. Call to action or next steps. Do you have a renewal or net new requirement for Oracle Java? Want to maximize cost avoidance for Java requirements? If so, contact the DLT team at Navy Oracle team at DLT for info on how to be part of the consolidated buy, or if you have any questions regarding this consolidated order. Requirement packages for this consolidated order must be submitted to NAVSUB no later than April 4th. Lastly, if you still have any further questions regarding Java or the consolidated buy, we will have office hours this Monday at 12:30 p.m. Pacific time, 3:30 p.m. Eastern time, and is open for anyone to attend to answer questions regarding the consolidated order. And with that said, that concludes the Dawn Consolidated Buy overview. Next up, you'll be hearing from Jerry Andrews, Principal Success Consultant with Oracle, who will be discussing Oracle Java in 2025, tackling challenges and driving innovation. Jerry, take it away.
All right. And now, as we used to say, for something completely different. I am primarily a software developer. I'm an application architect, and I work in the Java sales organization. And I want to talk a bit about the Java platform, particularly older versions of Java, like the Java 8 and Java 11. Oracle Java and this ecosystem have been very successful in building performance secure applications. But to stay successful, we have to continue to improve our ability to manage the Java estate. And that means a lot of things, from knowing how and where Java is used to reducing the attack surface on our deployed applications, and then to adding features in the language to improve readability, to make Java development faster, and to make our intentions clearer. And I'll describe what I mean by that in a little bit. I started working in Java in 1996. And in those days,
Jerry, real quick, I don't mean to, sorry for interrupting. Are you sharing anything right now?
I am not sharing, and that is a mistake. Thank you for bringing it up. What happened was I opened the share dialog and then I moved it out of the way.
No worries.
Thank you for mentioning that. All right.
No worries.
So here we are. Java in 2025. And by the way, I'm not a presenter. I'm more of a coder, a developer, and I'm most comfortable in a room with a whiteboard. Feel free to raise questions that occur to you as they occur. I like to be interrupted if so we can get that stuff taken care of right away. If it's something that I'm going to handle later in the presentation, I'll let you know at that point. All right. So I started working in Java in 1996. In those days, Java was a new programming language. The threats that were available were disorganized and primitive because the internet was relatively new. Breaches were rare and really secure enough by the approaches that we took. We had firewalls and DMZs, of course, but we weren't. Security was not a first-rate concern. The dominant language in 1996 was C++ on the web. Now, though, things are different. Threats are organized by nation states. They are serious. Breaches are very expensive and very common. The public is aware of what's going on. For the most part, even my mother-in-law, who lives right next door through that wall, and she knows and she's concerned, and so security is a first-rank consideration. In addition, our development cycles are very short, so there's a lot of demand on developers to do good, accurate work, and we live in a polyglot world. This is kind of the picture of what our environment looks like. There are a lot of attack vectors, vulnerabilities in the cloud, in the operating system, and then in the JVM, the JDK, and then the dependencies for our applications, and then the code we write as well. And so our goal is to reduce that attack surface by managing the JVM, by managing our applications, and by staying current on both the attack vectors and on the vulnerabilities that we might have. I'm going to focus mostly on this part of the onion, and the reason for that is mostly that we only have a few minutes together here. But of course, we need to be concerned about the whole thing. So managing Java, what do we mean by that? Well, in the most basic possible sense, we need to know what JVMs are installed, where they are installed, and what is running on them. That is sort of the most basic level of managing Java. But in addition, we need to know what the vulnerabilities of those installations are, what the mitigations are, what the update. We need to be able to acquire the updated versions of things that need to be fixed. We need to be able to identify deprecated and removed APIs and secure approaches that aren't secure. And then notification and deployment. We need to have notifications for those installations. And then we also need to be able to identify expiring certs, deprecated algorithms, exposed secrets. We need to be able to audit our architectures. We need to have responses in place for breaches and attacks, hopefully attacks rather than breaches, but we still have to have those responses in place. And we need status tracking, and then, of course, performance measurement and tuning and developer productivity and agility. All of this is what I mean when I say managing Java. And we're going to look at some of the pieces of this and what we can do with the tools that are available to you as Java subscribers from Oracle. A typical Java program kind of looks like this. There's the code that you write. That's my program. But then there's also the dependencies of that code, all the libraries that are included with that, whether or not you've brought them in-house, and then the JVM, and then the operating system and hardware that they sit on top of. Most Java programs comprise code written by vendors, and most typically there are dozens of third-party libraries that are included in that code. So we tend to focus on code security in our applications, but the majority of your attack surface isn't your code. It's everything else. And so what we do to mitigate that is a bunch of things. We manage our Java estate. We manage the packaging to minimize the application packaging to minimize the attack surface. And then we code for clarity. So back to the original theme, tracking our challenges, managing where Java is available, keeping the JDK and dependencies updated, reducing that attack surface, and coding for clarity. And then the innovation that allows us to do these things comes from the Java community process. In addition, as Java subscribers, you have access to the Graal VM native image tool, which will I'll show you how that significantly reduces your attack surface. And then coding for simplicity and clarity. Very famously, it is better to see code that is obviously correct than to see code where failures are not obvious. And then we'd like to be able to handle these new tools that are available to us, large memory models, maybe AI, very low latency, and polyglot coding that is typical for the kinds of environments we're in. So I'm going to start with management, and then we'll go to the other two tiers here. So let's talk, again, you've seen this. This is what I mean by managing Java, all of these topics. And there are software tools that are available to you, one of which is the Java Management System from Oracle. That covers the stuff that's in green and partially covers the stuff that's in yellow. So I'm going to look at that real quickly and show you like the kinds of things you should be able to do with any Java management system, which the Oracle JMS is one, right? So here's a display from that tool. Notice that it tells you what runtimes are deployed, including their minor versions, who the vendor is, what the distribution category is, and whether or not they need to be updated. And there's a distinction here between updates available and updates required. Java 16 hasn't been supported for many years. And so it's really important to know which versions of Java you have that are no longer supported and which ones updates are available for. And then in addition, it tells you which instances those are running on and how many applications and what those, if you drill into these, you'll get what applications are running on those specific versions of Java so that you have some chance of figuring out what mitigation is required. In addition, any reasonable Java management system should be able to interrogate your Java applications for the libraries they use and potentially any vulnerabilities that they might have. This is a demo system, and so we intentionally set this up with some vulnerabilities. But I don't know, you may recall the log4j vulnerability that surfaced a couple of years back. Your tools need to be able to show you whether or not you're using those libraries, and you need to be able to know if there are vulnerabilities and what the content of those vulnerabilities is. And that's what these click-throughs allow you to do, is to find those vulnerabilities and describe how they're activated. It's also good to know what applications contain those and whether or not they're deployed. In this case, none of these were deployed. They just happen to be on disk, but they aren't running. And so if you click through these, you'll find out, first of all, what that CVE is, what that vulnerability is, and then what library it appears in. And then finally, any reasonable Java management system should be able to tell you, should be able to survey your deployed systems for vulnerabilities. And here's an example from the Oracle Java Management System. There's a crypto analysis report that will cover things like expiring certificates, enabled protocols that are no longer considered secure, and a host of other misconfiguration and deployment issues that might happen independent of whether or not the code itself is secure. These are basic capabilities of any real Java management system. There are a lot of tools out there for doing this kind of analysis. I mentioned the Oracle Cloud Infrastructure, that's the Java management system I just showed you, but you can also go to all these other places and dozens of others that are not here to find the tool sets that you need for doing CVE detection and other vulnerability analysis. So that's sort of the basic set of skills that you need to do Java management. Now I'm going to pivot to how the Java release process helps to ensure that you're running a current patched secure version of Java. So back in the day, Java released about once a year. And like I said, vulnerabilities were rare. But as you can see, as we got into Java in 6 and 7 about 20 years ago now, the release cycle began to extend from once a year to once every 2 years to once every 3 years. And by the time we got to Java 8, we were only releasing every 3 years. And it turns out that, a big bang release every 3 years just does not meet the security landscape's requirements. We were waiting until features were ready, and as a result, the release cycle was complicated both by the fact that we wanted to respond directly and immediately to security issues and to defects, known defects. And the other thing was that we just need a release more often than that to get the latest features. So the state of the art in other software products back in 2017, let me go back a bit, back in 2017, 2016, when this conversation started, was that we just needed a much more rapid release cycle. So the at that point, Oracle had and Sun had open source Java, and the Java community process had been established. And through that process, we decided to go to the current long-term support version release cycle of Java. We now get a new Java feature release every 6 months. Last week, we released Java 24. 6 months ago, we released Java 23. 12 months ago, we released Java 22, and so on. We also do a consolidated patch update for every current release every 3 months. So the long-term support versions, currently 8, 11, 17, and 21, are patched every 3 months, as well as the current release version, which is Java 2024 right now. Every 3 months, there'll be a CPU release for that version of Java. A long-term support is targeted, version is targeted for every 2 years. So Java 21 came out a year and a half ago, and that will be long-term. Well, I'll show you in a minute. So there's long-term support versions every 2 years, and and those are continually patched until end of life. Once a quarter seems like a lot, but I want to talk about a little bit about what's in those every 3 month releases. So all the LTS versions, currently 8, 11, 17, 21, and the current release, 24, are patched every 3 months. The January 2025 CPU for Java 8, just as an example, included fixes for the last 3 months, including 2 security updates. One with a CVE score of 7.3, which is edging into my boy, I'm really concerned area. And it also included a fix for an earlier one with a lower score, both discovered in 2025. So very rapid response there. Also 20 bug fixes. Of more concern is the October release, which had 8 security updates. You can go to that link and see what they all were. 19 bug fixes, but also we removed trust from 9 root certificates. And the reason that's important is any website whose certificates or service whose certificates were anchored by one of those roots would no longer be considered secure. So you want those root update certificates as well as those security fixes as often as you can get them. Since Java 8 released, since the end of public updates for Java 8, Oracle has patched 161 security vulnerabilities discovered in that Java 8 release. And that, if anything, should tell you that if you're running Java 8, and I know you are, you should be updating continually just to make sure that those security vulnerabilities are patched. But also, almost 4,000 defects fixed without changing the API. So these are drop-in supports that are releases that you should be able to just deploy with no real issue. And you can see the numbers for the other LTS releases. So here's our recommendation. Update the JDK every time a new CPU is available, every 3 months. And if you've got that solid Java management system in place, you should be able to do this. So that's Java management. Let's move on to packaging. So we've talked about managing Java and keeping the JDK and dependencies updated. Now we're going to start talking about reducing the attack surface through packaging. And one of the things we're going to talk about is the GraalVM native image tool set. So let's get into it. The first thing that you want to do if you're trying to address any issue is measure. And for an attack surface, the software bill of materials is the measurement. An SBOM is basically a set of the inventory of all the components that are released as part of a distribution package. There's a bunch of tools for that. There's a Maven plugin, a Gradle plugin by Cyclone, for example. SIFT does this for container images and file systems, and we're going to look at some SIFT output in a bit. Well, almost right away, actually. And as a sample application, I'm going to use the Java 18 simple web server. It's been built into Java since Java 18. It's not a separate application, but it gives us the same sort of view of what a footprint might look like. as a deployed application would look like. So we're going to use that Java 18 Simple Web Server as our example. Here's the command line. And what you would do is package a JDK either in a container image or as a deployable onto a Linux distribution in order to do this, in order to deploy this JWeb server. And I'm going to run the SIF tool against a bunch of different containers, and we're going to look at what that footprint looks like. So this is SIFT output for one of the examples I'm going to show you, the Java 21 distroless version of Debian 12. And this is the kind of what the SIFT output looks like. It counts the packages and the file digests, the file metadata, how many files there are, how many executables there are, and then it produces a full SBOM of each package. So if you look at a couple of different distributions, here's an example of that SIFT output for the Debian Slim distribution, which is kind of the default for a lot of Java deployments. You'll see that there's 103 packages in a full JDK distribution on top of Debian. Debian Slim, that is. The packaging size is 785 megabytes. So that's like the small, slim, normal distro. There are 779 executables, different commands you could run on that distribution, and about 3,000 files. Another really popular one is the Tamarin distribution from Eclipse. Slightly larger number of packages, slightly smaller size, which is interesting, but more executables and more files. This is a pretty large attack surface if you think about this. Almost 860 commands that an attacker could use to get access to that system. So back at Java 19, back in Java 9, the version right after 8, Oracle reorganized the JDK into modules and introduced the first major security change in the Java platform since, well, the beginning of Java, really. And that was the introduction of the module system and the JLink Java linker. What JLink does is takes a deployable application and it goes through the entire set of modules and removes anything that's not being used by your application. So the particular choice I used is unfortunate, I guess, because the JWeb server uses almost all of the base platform for Java. And so let's look at what the JLinked version of that distribution would look like. So again, running the packager and running an SBOM, we see that if we use, so these are the two we already looked at. If we use a distroless version of the same package, that is without basically anything in Linux that is not needed to just run that web server, we can get the size of the distro down to 333 executables and 1,341 files. Still a pretty large attack surface, but quite a bit smaller than the full Linux distribution. If we run JLink, we can take out another few percent. Now, for many Java applications, this would be quite a bit smaller, but JLink allows us to reduce the size by a bit and the number of executables by a bit and the number of files by a bit. And as in all of these things, your mileage may vary, right? So you need to actually run JLink on your application to see if you can get a smaller distro with a smaller attack surface. There are other approaches. So one of the things you get with a Java subscription is GraalVM. GraalVM is a standard JDK. It'll run your application just like Oracle Java does. But in addition, it has this native image component, which allows you to compile your application. What it does is basically takes your jar files and your class files, and it builds a native executable for Linux or Windows or Mac OS, or whatever your target distro is. You can link that distribution a number of ways. You can include shared libraries, which would basically dynamically link your application code to things that are part of the Linux distribution. You could do a mostly static build that includes many of the libraries, but not the hardware interface library, glibc. Or you can do a full static distribution, which is somewhat less portable, but it matches your target exactly. And let's look what that footprint looks like. So here's those three: dynamically linked, mostly statically linked, and statically linked. And then by choosing the distribution you use, you can get this footprint down to 18 files, 22 meg. I'm sorry, 80 files, 18 executables, and 22 meg. Or you can use a distro like this, which is slightly larger, has more files, but only has one executable in it, which really reduces your attack surface. It also takes all of the Java out of your attack surface, because now what you have is a single executable file rather than a general purpose JDK. So this is an approach to reducing your attack surface uh, by managing your packaging as you deploy your application. There is a restriction here. This is really only applicable for things which run on versions of Java after Java 8. So Java 8 gives us some capabilities, but we have to focus on parts other than packaging. Once we're off Java 8 onto a more modern version of Java, then all of these things apply. Okay, so we've looked at reducing the attack surface. We've looked at GraalVM, and now I want to talk a little bit about coding and simplicity in coding that comes from the Java platform. How are we doing on time? It's 10:36. We're all right. All right. So I mentioned this earlier. Tony Hoare rather famously said there are two methods of software design. One is to make the program so simple there are obviously no errors, and the other is to make it so complicated there are no obvious errors. And I think you can guess which one we'd rather be in. So Oracle is working through the Java community to continuously improve the developer experience. And these are just a few of the projects that are currently going on through the OpenJDK community, hosted by and driven by Oracle. But I want to focus today, for our purposes, on just these three programs. Note that this all starts at OpenJDK, where we're trying to be as open and transparent as we can with Java development and include as many people as we can. The noteworthy projects here are Amber. With Amber, we're trying to make Java more approachable. Like each Amber feature is aimed to make Java either more readable and writable by removing a boilerplate and ceremony or giving us new tools. The Amber project has resulted in records, stream processing, type inferencing, switch expressions, which complement switch statements, pattern matching, block strings, lambdas, and just a whole bunch of tools. And it continues. This continues to work both to improve developer productivity, but also to make our code clearer and easier to understand. Project Loom has given us, this came out in 2017 with Java 19. This gives us lightweight threads for IO bound applications. This gives us a lot of scalability, much more scalability than you would expect. And in addition, this allows us to, the use of lightweight threads allows us to write blocking code. I don't know if you've written a lot of multi-threaded code, but if you have, you've had to deal with the complexity of thread pools and managing futures and asynchronously responding to the way to thread issues and thread completion. None of that applies once you start using lightweight threads. You can simply write a declarative thread that starts at the top, blocks when it needs to, and exits when it's done without affecting performance. And this just makes multi-threaded code vastly easier to read and much more likely to be correct. And then finally, Panama, which replaces JNI, the Java native interface. Panama is much more efficient than JNI, and it's much more readable. There are a lot fewer steps between declaration and use. And this is the tool that enables you to leverage any application with the C-based libraries, in both directions, calling Java and calling out to those applications, which allows you to do more transparent, more straightforward hooks into tools like device control and machine control. And I just talked to a guy last week in a trading application where he was working with extremely time-sensitive actions that needed to be executed with nanosecond precision. And they were able to do that by substituting a C++ library for Java code at a critical point in the process. That's the sort of thing that you would use Panama for, and the new APIs. I have sort of mentioned in passing OpenJDK, and I want to clarify the relationship between OpenJDK and the Oracle JDK. OpenJDK is the place where open source happens. It's the open source implementation of the Java platform. It's a source code project. The OpenJDK organization is the governance and stewardship organization for Java. The Java language is specified and built through OpenJDK. Oracle is a key contributor to OpenJDK, and our architects are extremely active. And when Oracle Java releases, so Java 24, which Oracle just released, is a build of OpenJDK. The Oracle JDK itself is a distribution of Java technology by Oracle. So it implements the language spec as specified by OpenJDK, and it uses the OpenJDK code to build that JDK. But it comes with Oracle certification for performance and stability. And also, Oracle maintains that release cycle that I described to you earlier, where every 3 months there's a consolidated patch from Oracle for the current release cycle. And that continues well beyond the point where publicly available updates are being made. So that's a relationship between Oracle and Java. And I want to say, the OpenJDK and all of the infrastructure around Java is sort of that rich ecosystem is why we use Java, right? It gives us the ability to do really powerful things because we have these open source platforms to help us get code built. The Java community process helps decide what the features of Java are going to be to enable this large, rich ecosystem. And it allows that all to happen with a standardized approach and open collaboration with every organization that wants to use or participate in the development of Java. Oracle is a major contributor to OpenJDK. Over the last few years, we produced over 80%, well, right at 80% of the patches and fixes to OpenJDK. But all of these other organizations are active participants in the delivery of OpenJDK. And so we like to say that, Oracle is the premier build of OpenJDK, but be advised that there's all these other people are participating. So that's really all I have to say about managing your Java estate. We've got, on the challenge side, we've talked about managing, keeping the dependencies updated, JDK updated, reducing that attack surface, and coding for simplicity. The innovation really comes from the Java community process. And it's vital that that continue to be the key driver, because that's what makes sure that Java matches the community's needs. As subscribers, you have access to native image, and you should leverage that if you can. And you should also strive to code for the simplicity and clarity that's needed to make sure that your code is secure. And then, of course, all of those tool sets enable Java to handle AI and large memory models and low latency issues and polyglot loading and all the other things that we want to do as Java developers. As Java subscribers, you have access to a bunch of things. And I want to touch on those just really briefly before we go to questions. You have access to the Java Success Program. And what that means is you have access to, among other things, me and my colleagues in the Java Success Program. And what we do, among other things, is we have workshops that are available to you on a variety of technical topics. I can drill in on any of the subjects we just talked about. I can talk in the context of your development activities and your deployment activities about performance and scalability and security, and I can do that at your site, uh, hand in hand with you, with whatever your actual problems are. And all you need to do to activate that is reach out to uh, your solutions advisor, which is Brian Beiser. He's on this call, or to me directly. And then what I will do is refer that to Brian, and then he will schedule me. You have access to the Oracle JDK, the premier JDK, in my opinion. You have access to ongoing Java updates well past the end of public updates. And you have access to global Oracle support. Whether or not you know it, all you have to do to get support ticket opened on any Java subject is open a ticket, and anyone can do this in your organization. You have support for the entire Java ecosystem, including third-party libraries, runtimes that are not Oracle runtimes. We have triage support with our Java experts. We have global coverage. We have any language, most likely, that you're going to speak. We do not have Maltese, which my friend and colleague Albert Attard speaks as his native language, but we do have 27 languages, one of which is probably one you speak. You have access to Oracle GraalVM, the Enterprise Performance Pack, which is a performance upgrade for Java 8 loads running headless on Linux. Runs the Java 17 engine underneath the Java 8 API. And you have access to the Java Management Service, which is, as we saw, a cloud service for managing your Java deployments. The most important thing I want to tell you is you're not alone here. We're here to help. It's our job. It's my entire day job is to make sure you're successful in using Java in your ecosystem, no matter what your use case is. Someone raised their hand. Jason, what's your question?
I think we're good. I'll give him the right to chat if he wants to chat, or if he wants to. Well, someone's looks like already did. Jason, you've been given the permission to use your mic. So if you want to unmute, if you have your question, you can. Well, looks like he didn't need it and left the
You
room
just
rather.
mind, yeah? All right.
Yeah, Jerry, that was a great presentation. Thank you. Yeah, I was that the last thing you wanted to cover?
That's the last thing I have to cover formally, but let's see here. I'm looking at the chat to see if there's any questions. It doesn't
I
look
don't
like
think.
anyone's actually raised a
Yeah,
question.
yeah. There's no questions thus far. Yeah, feel free, any attendee on the call, please feel free to ask any and all questions. I do see John Pendergraph is on the call, or maybe John Pendergraph team. I know we've had some back and forth the emails about Java. It might be a opportune time to ask those questions to Jerry.
Well, if there are no questions, I'm happy to hang out until the end of the hour. Otherwise,
Yeah, let's well, how about we'll give everyone a minute or two
yeah, there
to
was a
see if
kind of
they
a
come up with
torrent there
questions.
of material. Are there any coders in the audience? People who write Java for a living? Oh, here we go. How does JLink mesh with the mantra of write once, run anywhere? All right. Excellent question. Uh, JLink is uh, JLink builds a custom JVM for the platform that you run it on. And so you would need to build a JLink image in each environment that you want to deploy in. Because what it does is extract the components that you need, and it builds a little custom runtime for that platform. Does that answer your question, Malcolm? It's hard because he doesn't. Yeah, he says yes. Good. Okay. I want to riff on that a little bit. So the Java module system is the first in a bunch of steps that we're taking to make the runtime secure by default. And that requires that we have tight control over the visibility of components. Getting onto the Java module system is kind of a security key. And if you haven't started that migration, I've got a 2.5 hour workshop to help you figure out how to take an existing application and get it migrated onto the module system. It's really a key security step. Once you're on the module system and you've got a good module path straightened out and you know what the boundaries are, you've already taken a huge step to reducing the size of the attack surface of your application. And then running JLink on it reduces it even further by eliminating any code that you're not actually using, or any libraries that you're not actually using. If you want to remove code that you're not actually using, you probably need to compile.
Thanks for that. Thanks for that, Jerry. Again, feel free to ask any and all related questions or any questions related to Java or if
Or your
anything, the
contract.
Java consolidated order. Yeah, or the agreement. Exactly.
Okay, we should have put a shill in.
Maybe, maybe.
That's all right. That's all right.
Well, it seems like we may not have any more questions, but if any questions arise after the call, please feel free to reach out to myself or to Jerry. His contact information is going to be in the presentation, which will be made available in the marketplace. But if anything, we'll give everyone back 9 minutes of their time. Thank you, everyone, for joining on today's Technology Spotlight. We look forward to seeing you next months. Have a good one.